Let us have a look at the diffraction, that is Fresnel's diffraction at a circular aperture. Aperture means a gap. Suppose we have a circular hole and let S be a point source. This AB be the circular aperture. We are drawing this in the plane of the board so that it will look like this. Actually, this is a circular aperture. Since we are drawing that circle in the plane, it will look like the gap AB. And the wavefront from the source, point source, since the source is point source, the wavefront will be circular. Let W1, W2 be the wavefront. Let S be a monochromatic source. Monochromatic source means source which is having only one wavelength, single wavelength, that is monochromatic source. And W1, W2 is the wavefront. And here we have a screen. And we are obtaining the diffraction pattern on this screen. And let P be the axial point P. To find the pole with respect to the point P, we draw a straight line connecting S and P, and it touches the wavefront at the point O. O is the pole of P, pole with respect to the point P. And here this is a screen, and we will be obtaining a diffraction pattern in the screen. If we observe the screen from this side and we observe the screen, the pattern obtained will be like this. Alternate dark and bright bands. This P can be either bright or dark. Can be either bright or dark, and that depends upon the distance OP. Let B be the distance OP, and depending upon the magnitude of the distance, the center will be bright or dark. And that dependence is due to the fact that the zones, number of zones will be depending on the value B, because we know how zones are constructed. If this is a wavefront, zones are constructed like this. This is a first zone and the distance is B plus lambda by 2, and this is the second zone. The distance is B plus lambda by 2 plus lambda by 2. Again, to the third zone, the distance is B plus lambda by 2 plus lambda by 2 plus lambda by 2. That is, it depends upon the distance B. If this is a circular aperture AB and this is a source S, and depending upon the distance B, that is the distance between O and P, this is the distance B, depending upon the distance there will be zones, and zones are constructed with pole as center. Let the distance be such that the aperture AB contains only one zone. That means the amplitude from the first zone, let D1 be the amplitude from the first zone, and here we will be obtaining an amplitude D1, that is intensity is the square of amplitude D1 square, and that will be the intensity if there is only one zone, and that will be depending upon the distance B. If this distance we changed this distance, that is the distance between aperture and screen. We have changed it so that there are two zones within AB. That is, D1 is the amplitude from the first zone, and we know second zone is having lambda by 2 path difference. That is, second zone amplitude will be having negative sign with respect to the previous zone, that is with respect to the first zone. That is, D1 minus D2 will be the amplitude obtained at the point P. That intensity is D1 minus D2 the whole square. D2 is actually less than D1, but since this is a first zone and this is a second zone, D2 will be approximately equal to D1. That is, D1 minus D2 will be very small. We can approximate it to 0. That is, in this case, P will be dark. That is, if AB contains only one zone, amplitude from the first zone contribution is D1, and the intensity at P is proportional to D1 square, that is, center will be bright. If the distance B is such that there are two zones, the amplitude contribution from first zone, amplitude contribution from second zone is negative, that is D1 minus D2, that will be approximately 0, that is center will be dark, and here center will be bright. That is, P becoming bright or dark depends upon the number of zone, and the number of zone depends upon the distance B, the distance between the pole O and the screen P. That OP, the distance OP determines the number of zones, that is, the distance B determines whether the center is bright or dark. That is, if we are changing this distance, keep AB same, then we are keeping screen at a particular distance. Again, we are moving screen towards this aperture. We are keeping at a particular distance, then we are changing the distance, then we are keeping the screen at a somewhat a distant point. This is also a different distance B, and depending upon the number of zones, center will be sometimes bright, then we have changed, sometimes it may be dark, and depending upon the distance, bright. That is, if we move the screen towards the aperture or away from the aperture, the center will be alternatively bright, sometimes it may be dark. That is, it can be bright or dark, and that depends upon the distance B. And that's about the diffraction pattern and the center being bright or dark, and this is the Fresnel diffraction pattern we obtain in the case of a circular aperture.